Did you know that UW Eau Claire is currently in the works of installing solar panels on the rooftops of McIntyre Library? The project was proposed in 2010 based on the H&H assessment of the UWEC campus and is expected to be finished later in 2013. Most students are unaware that about $10 of their tuition goes towards the Green Fund, a segregated fee paid per semester and handled by the Student Office of Sustainability for the specific purpose of reducing the university's environmental impact. The average American uses about 10.5 kilowatt hours of electricity each day. If we thought of electricity as a volume, this amount would be equivalent to a six-pack of beer. On the UW Eau Claire campus, we use about 53,340 kilowatt hours of electricity each day. If we consider this value in volume, it would be equivalent to 180 half-barrel kegs. So how are we getting all of this electricity? To gain the electricity for most parts of the United States, coal is burned. The process entails human forcing, where there is a chemical change in the atmosphere from human involvement. When coal is burned to produce electricity, CO2 emissions go into the atmosphere. Since there is an added greenhouse gas in the atmosphere, the sun's rays that heat up the Earth cannot escape as easily, therefore further heating up the Earth's temperature. The current electricity needs at UW Eau Claire are being met from outsourced energy providers, such as Xcel Energy. This means that we are completely dependent upon Xcel to produce all of the energy we need to run electricity on campus. Solar energy is a renewable source that does not emit CO2 or any other harmful gases into the atmosphere. The installation of solar panels on McIntyre Library is the first step to help UW Eau Claire become a more self-sufficient campus. At this point, you may be a little skeptical. How do solar panels convert the sun's rays into electricity? How much energy will these solar panels provide for the university? And most important, what will be the recovery cost?
To understand these three questions, we first need to learn how solar panels convert sun rays to electricity. Imagine the sun's rays hitting solar panels on a flat roof. Inside those panels are little cells called photovoltaic cells or PV cells. They're assembled in a panel and then connect to an electrode array, a device that stimulates a pattern of electric current. The stimulation occurs when the sun's rays strike the panel like a lightning bolt strikes the earth. The sun's rays contain photons, and once that ray strikes, a current is produced containing electrons. Photons and electrons are attracted to each other just like a magnet is attracted to metal. The electrons are excited by the photons. The solar panel is lined with a cell that contains protons. They further pull those electrons and begin the stimulation of the electric current. The current generated is called direct current. But we need what is called alternating current to, say, use lights, toasters, microwaves, or charge cell phones. The inverted current can then be run through wires to power our electrical devices. So how do we know how much energy solar panels could capture at UWEC? To find out, a panel manufacturer called H&H Solar Energy Incorporated conducted what is called a solar site assessment. The solar site assessment evaluates 5 factors that can help predict how well a solar panel will perform at a given site, including life expectancy, available sun exposure, roof structure, CO2 emission reducer, and recovery cost. Consensus by several sources say that the average life expectancy of a solar panel is approximately 25 years. These 5 factors have been monitored at UW-Whitewater. Their campus results can give us a good idea of what we can expect here at UWEC. Though UW-Whitewater have over 30 buildings with appropriate roof structure and sun exposure, they only installed panels on their Highland Hall building. They currently have the following kilowatt hours per year and reduced CO2 emissions. However, UW-Whitewater is not exactly like UWEC. They have many more buildings with appropriate sun exposure. The UWE Solar Site Assessment has identified 5 buildings here that are appropriate for solar installations: Haas Fine Arts Center, Oak Ridge Hall, McIntyre Library, Chancellor's Hall, and McPhee Center. And Whitewater is further south than Eau Claire, so they have a greater amount of insulation. By using the information from places like Whitewater, H&H has calculated the predicted performance of UWEC solar panels. The bottom line is that H&H predicts that installing solar panels on these 5 UWEC buildings could help reduce our CO2 emissions by 236.3 tons.
With the allocation of solar panels on McIntyre Library successfully going forward, there should be nothing stopping us from executing the entire project as assessed by H&H. The McIntyre solar panels will provide roughly 2.1% to our own electrical needs in McIntyre Library, saving an estimated $3,800 per year off our Xcel Energy bill and reducing our carbon footprint by approximately 21.9 tons of CO2 emissions. Students are currently paying $10 a semester towards the green fee. For just fall 2013 through spring 2014, we could increase the green fee to $20 a semester. An extra $20 for the academic year? By 2015, we could install all of the solar panels on the proposed buildings and reduce our carbon footprint by 236.3 tons. Interested in pushing forward the proposed project? Would you like to be involved in the decision-making of how your tuition money goes toward the green fee? We encourage you and your friends to contact the Student Office of Sustainability at the following email, or Chancellor James Schmidt at the following email, with your ideas and see how you can assist ongoing decisions towards making UW-Eau Claire more self-sufficient and carbon neutral. Let's help reduce the UW-Eau Claire carbon footprint and take this step to help the major efforts in combating global warming and all of its negative effects on Earth.